Recap from yesterday class. We talked about energy. So energy, you have kinetics energy and potential energy. And we come up with this equation. T1 kinetic energy plus V1 is the potential energy. And the work done. And this one is for the work done non-conservative. For example, type of work that fall under non-conservative is friction force, right? And equal to the incident after the incidence, which is kinetic energy after the incident plus the energy after the incidence. Okay, so kinetic energy equation will be half mv squared. Okay, by now you should able to memorize what is the kinetic energy equation. Half mv squared. What is the energy? Two type of energy that we have discussed. No, there are a few types. Energy, potential energy. So here is potential energy. One is a spring energy, and one more. Okay, one of the example is spring energy. So we will look into tutorial later on when we need to recall all this information. Okay, so if only conservative force is considered in your calculation, so you can cancel out the friction force over here, and your equation will only arrive at kinetic plus potential energy before equal to energy after the incidence. Okay, so this equation also called mechanical energy conservation, or conservation of mechanical energy equation. All right, so yesterday we discussed about the potential energy and kinetic energy on the balls, and we have proof that the energy doesn't change from the top and middle and before hitting the ground. All of them, the total energy equal to E equal to WH or MGH. Okay, W equal to mg, so total energy equal to mgh if we consider a falling ball condition, right? Okay, so yesterday we have proved all these cases. Okay, next we look at what happens if you have a system in a system. So inside this system, there are lots of particles. For example, in the water, right? So you want to calculate the energy inside the system. So you add some symbol in front the kinetic, some symbol in front the potential. Same with this one and this one. Okay, same with. So this is the mechanical energy, conservation of mechanical energy. Kinetic potential, kinetic potential. Right? On the left is before, on the right is after. Now we look at tutorial question. So, okay. So if you read question number 8, it's actually conducting an experiment. It's a prototype, aircraft prototypes experiment where you will swing the aircraft to a certain degree, and then means you tie an aircraft body at a certain angle. Okay, and then you have a release rope here. A to C is a release rope where you charge the energy of this object. Energy here referring to kinetic energy and potential energy. Okay, so when you pull the object from the ground, you're actually charging the potential energy. However, be careful on the potential energy on the datum. We have discussed about the location of object and the datum. This one is below datum. Huh? This object is below datum. Okay, so this object was pulled at a certain angle theta, and the rope is 20 meter. What happens if you cut this rope? This object will swing in the circle motion. All right, because this one is fixed. So when you cut this one, this object here will swing in the rotation of a circle. So when you have an object move in a circle, what does it mean? You're having a curved linear motion. So curved linear motion, you're having a normal and tangent, tangent and normal axis. Okay, and so on. So these are the things that you can prepare before you answering. Look at the question, look at the diagram given, try to link to all the chapter that you learn up to this date. Okay, so yeah, so actually there's a photo. I didn't put it here because I need the space here. So in one of the experiment where they tie the airplane at a certain angle with the radius of 20 meter, and then later they will release this rope, and this object will travel from A to B. So to test the response of an aircraft during a crash, so it's a crash test. So the plane is having a mass of 8 megagram. Okay, 8 megagram. Why megagram? Is just a trick. It's just a trap for the student to make mistakes. You're waiting you to make mistake in your calculation. Why? Because the unit SI in your calculation is kilogram, not megagram. Okay, it's a signal for you that don't make mistakes in your calculation. 8 megagram, you need to change 8 megagram into kilogram in your calculation. It's hoist back until angle becomes 60 degree, means you will pull from here until 60 degree, and then pull back cable AC and release when the plane is at rest. What mean by this sentence? Plane is at rest before the test given. You have your V. You have the velocity in the question. So anything that link with velocity, you need to pull from your memory. Later, you need to use. Okay. The most obvious one is the Newton equation. There are 3 Newton equations. So you might need to use one of it. Determine the speed of the plane just before it crashed into the ground, means from A until here. Until here. Crash into the ground at angle of 15 degree. So from 60, it crashed into the ground at angle of 15. Also, first you need to find the speed at this location B here at 16 degree. 15 degree. What is the maximum tension developed in the supporting cable during motion? So during the swing, what is the tension cable? What is the tension experienced by the cable? That is part B, or second question. Ignore the size of the aircraft or airplane and effect of lift because of the wing. So this question asks you to ignore the lift motion. Okay, and focus on chapter 3 equation. All right, so how do we solve this question? Of course, first one, you need a free body diagram. Okay, so since the force of the cable does no works on the plane, so you must obtain using equation of motion, because the cable that relate to your plane here, once you cut, it doesn't travel, the cable doesn't travel, right? Once you cut, it doesn't travel, so no no work done. And then this one swing. Although this one swing, this cable do not elongate or do not become shorter. So this cable doesn't do any work, right? Although it swing from one place to another place, but the length still same. Okay. So we need to find the speed of the plane at B. Okay, we need to find the plane before it crash at the angle of 15 degree from here. Okay, so I pull the diagram to this corner here. Okay, apologize for this one. I should hide this one. Okay, so I pull a plate. I draw a free body diagram of this aircraft. So there's two axes on all the object. Or in the exam, you don't need to draw the object real shape. You can use square shape, round shape, rectangular shape, standard shape, as long as it represent the body. Then you put in the axis, right? You start with the free body diagram with the axis. Important that you know where is positive, where is negative. Then you know, as long as you have an object moving in the curved linear motion or in the circular motion, you will have normal and tangent direction. Okay, I think this one is more than 5 to 6 times I mentioned this one when we come to curvilinear motion. Okay, I think more than 10 times. Right. So every time you see a curvilinear motion, always expecting you are giving normal and tangent direction. Then you start with the forces on the object. First one, sure we'll have the weight or the acceleration, gravity acceleration effect on the mass of the object, which is the weight. W equal to mg. This will be the first force on all the object you draw. All the free body diagrams sure have weight. Okay, I give you hints already. Sure have weight one. Then there will be a tangent of the cable pulling the aircraft. There will be a tangent of tension of the cable T. Okay, then you put in the angle over here. So when you reach position B, the angle will be 15 degree. Okay, will be 15 degree if you measure from the vertical plane. The angle will be 15 degree. Okay, 15 degree over here. Okay. Is there any other force? There's no more force, because if you look at the object itself, it only tied to the cable, and the mass of the aircraft is making the forces pulling down here. There's no external force making on it. Okay. All right. Next, we look at energy. So for potential energy always have datum. Okay. So just a reminder again, if you see datum in a question, you cannot run away from potential energy. Okay, so it's a few hints. So conservation of energy equation, you have on the left will be before, on the right will be after the event. So if you talk about conservation of energy, you only consider the mechanical energy, which consists of kinetic and potential. Okay, kinetic at point A, potential at point A, kinetic at point B, potential at point B. The rest is just expansion of your equation. You look at position A, what does the kinetic you have? So kinetic equation half mv square. You just write sub A there, just represent location A. What is the potential for A at position A here? What is potential energy? mgh WH, right? mgh, or in your physics class, you're more familiar with mgh. You can straight away write mgh. I will still give you correct, right? W, weight times the height of A. Y negative, I already explained now, Y negative, object below datum, you get negative potential energy. If the object above datum, you get positive energy. Okay? There's a negative sign there because datum is below, object is below the datum. If the object is above datum, you get positive potential energy. If the object is below datum, you get negative sign there. Okay. Okay, before I forget, imagine I re-engineer this question. I have an object that overswing. I have an object that overswing to this location, that the object already passed the datum. Are you able to find the energy at this point? Okay, take that as your homework. Think, what happened if I change this object to become a space object, and I swing, I cut the string here, the object swing to this location. This location is above datum. Are you able to find the speed at that point? Okay, I give you hints already. Okay, back to our tutorial question. For point B, at point B, after you release the datum here, the kinetics energy equal to half mv square again, but in B. And what happened to the potential energy, mgh again, y negative, because at point B is still below datum. That's why you get negative. Okay, so you have negative energy before, negative also before, after. Okay, any question on this equation? Any one of you want to ask me question about this equation? Everyone good? Sivendra, you okay?
Yeah, so far okay, sir.
All right, good. The next is just substitution of all the information you have here. Okay, some of it you need to do. Okay, some of it you need to do some transformation of information. All right. Okay, so I put a remark here. Y negative is below the datum. Okay, so I do a little bit of calculation for you. At position A, velocity 0, so that's why kinetic energy 0. mgh, again change megagram into kilogram, you get 8,000 kilogram. G 9.81. What is the H? H is 20 cos 60. Okay, so okay, HA is over here. Or you can say you are measuring from this height datum here. This is your H. Okay, you're measuring this height here. Because your datum is from here. You're measuring this from here to here. This is your H. Not here. Don't do the wrong calculation. Here and here not. Because your datum is above. So you're calculating your mgh. Your h is from here. It also explains why negative there. Okay, so this is the error of mistakes in test and exam. Okay, mgh, I show you already. H is here. So how to find here? Use trigonometry. Yung cosine relationship, cos relationship in front and hypotenuse, right? Opposite and hypotenuse, you get cos, 20 cos. Okay, we have done on the left hand side. Right hand side, still same, mass doesn't change. Mass, velocity, we don't know because the question asks us the speed. So this actually is our objective here. Minus WH means mgh again. So M still same, convert megagram into kilogram. G 9.81. H is here. This is your H. Not zero. H is not zero. Be careful. This one also famous mistakes done by student. When they assume datum is from here, but the question already give you here datum. Don't assume. In exam, don't assume. Read carefully the question. So here, the datum is here. So the end position is here. So you are measuring from datum to here. Your H is this one. How to get H? Also cos 15, right? Cos 15. Oh, this is your H. Sorry. This is also your H. Okay, your H. So how to get your H? Cos 15, right? All right. You substitute all the value, use your calculator, you'll get 13.52 for V2. Again, V2 is square, so you have to use the square root to find this answer. This is just a final answer for you, just a reference. Okay, so up to here, I hope every one of you understand what is happening. Okay, the numbers will change in test also in final exam as long as you understand what are the standard procedure. First, read the question, convert the question into free body diagram. Weight will be the normal thing that you will see in your free body diagram, and axis will help you to draw your forces. In this case, because if you are aware this one moving in the curvilinear motion or curve motion or circle motion, that's why you are seeing normal and tangent axis. Okay. In test, let's say you accidentally write this one is y, this one is x. If you accidentally write this one y and x, I will still give you correct. It depends on your question, your answer later on, when you calculate about the normal axis and t-axis. Okay. Okay, so if no question about this page, I will move the free body diagram to this space here. All right, and you have your VB as your answer that you need to substitute to find the maximum tension developed during the motion. We need to find the T. Okay, so we call the equation of motion F equal to ma. Equation of motion F equal to ma. In this case, tension is in normal direction, so we look at normal direction. Okay, so all the force in normal direction equal to mass multiplied by acceleration in normal direction. On the left-hand side of the equation, you focus on all the force. On the right-hand side, you focus on the acceleration in normal direction. I think the next step you can guess if you're familiar with curvilinear motion. There is a special equation when you calculate for acceleration in a normal axis. They already have a standard equation, right? Call that equation to calculate AN, okay, when you involve collinear motion. Okay, so, okay, what is the difference now? Okay, this one is just the direction. Important is you know the direction. Right, in exam, if you forget to put this section, I will still give you correct. It's just a guideline for you to show that what is the direction of your motion. So you have tangent minus mg cos theta by free body diagram. You are looking at normal direction. So you need to switch this one to this direction and this direction. So this one you break into two. One is normal, one is tangent. So you are solving for normal direction. So you have mg cos 15 here, or cos in this one is just a general formula. So t minus mg cos theta equal to m. This one, normal acceleration already learned in your chapter 1. So v squared divided by radius of the rope. Okay, v squared divided by rho, or in the radius of the circle. And if, okay, and if the rope radius is not given, you can calculate with one more equation for the radius. If you forget, go back to the chapter 1 and find the radius for collinear motion. There's one specific that there's a dy dx d square d square y over dx square. You need to do differentiation one. If your movement is having a y equation, in this case you are very lucky. This one you have a very perfect circle because the line doesn't change and the radius is given, so you cut short your calculation. Okay, so this is a standard equation. Okay, the rest is substitution. Okay, if the equation makes sense to you, positive, negative, positive, and so on. Okay, substitution. T, you don't know. The question actually asks you about the T. M, again, change to unit SI, megagram into 1000 kilogram. 9.81 cos 15, mass 8000. V, how you get V? Just now you find from section A just now, 13.52 square. So if you done some calculation error in section A, you have wrong answer here. But if you write the general equation, you still can secure some mark here. Okay, so general equation is important to help you to secure some marks. But if you are confident enough, to use the value, go ahead. I will still give you marks, although you do not write this one out in your answer. But if you, provided you give the correct numbers, in your answer, let's say this is the question in exam. So in the question you give me this is your answer, I will still give you marks for this one, although you don't write this one in your answer. I will still give mark, assuming you know this one. Based on all these numbers, I know you know this equation. So I will, in your answer sheet there, I will still give you marks for equation. There's a marks for equation. Then if you calculate the wrong velocity in the section A, then sorry to say you don't have marks for the following steps already. But if you write this one, you have marks. Okay, you have marks for this one and this one. Okay, so you rearrange. You can either write in 149,000 Newton or put in kilonewton. Okay, tension equal to this one. Any question? Any question for example number 8?
So far, no, sir.
Good, yeah? Okay.
Okay, sir.
So the next one, we go to one more example. I think can, we go for one more example. Then we have a short break. Okay, let's look at your last question, a bit long question. Do you guys need break? Can continue? Can do you guys need break?
Can continue, sir.
Can all right. So if you need break, just let me know. Okay, so you have this one in your tutorial handout, I think the last question. So you have the setup of this system here. So what you have something on the top here, and then you have a spring here. You have two spring inside here. You have two spring system. You have spring A and spring B, quite complex system. And you are given the K spring stiffness or spring stiffness for A equal to something. You're having the B K stiffness for B. So you have two spring there. And you're given the original height of certain spring. For example, 1.3 meter for the spring A. Sorry, for spring B. Spring B is inside. So original height of spring B is 0.3. Original height for spring A is 0.4. And from the height of A to the bottom of this object here is 0.75. So original height, this object from the floor is 0.75 plus 0.4 meter. So this is the original height before anything happened. Okay. So before we start, actually from the object itself, you know how many equations that you will see in your calculation. One equation for this object, one equation for spring A, one equation for spring B. You have three equations for the whole system. One equation for one object. All right. Then you look into the statement here. It gives you more information to help you solve the question. You have the object R mass in kilogram, released from the rest. So it gives you the initial condition, which is V initial, which is V1 equal to 0 from rest, right? From rest. 0.75 from the top of a spring. Means is 0.75 from the spring. Okay. That has a stiffness of so and so. Second spring B have so and so stiffness. Is nest in A, so it means that you have a composite spring there. Determine the maximum displacement of A needed to stop downward motion of the ramp. It asks you to find what is the maximum displacement of A spring here when this one go down. When this one go down, before you start solving, you know that what kind of energy you have. You have kinetic energy and potential energy, but before start, you don't have kinetic, only charge up 100% potential energy, mgh here. So the 100% mgh is going to transfer to A and B at the same time. So the question asks you, what is the maximum A can move with B? With B, the stopping power of A and B together, what is the maximum displacement of A? Okay, this is a very real industrial problems. If you're working in a design firm, this will be, you apply what you learned today in your work later. Okay, if you're designing some stopping mechanism or in robotics projects, right, you need all these things. Okay, determine the maximum displacement downwards, and the unstretched length of each springs is indicated in figure. Ignore mass of the spring. Okay. So how do we solve? First is potential energy. So what is the assumption when you solve this question? You assume that when the ramp go down, this ramp go down, both spring will come to rest. So you will compress both springs when it come to rest. So A will be compressed, B will also compress, both spring will contribute to the stopping power. Okay, you need to have this assumption before you start. If not, then you will miss you'll miss member B function inside there. Okay, although A is a bit longer than B, but you need to consider the contribution of B spring in the stopping power. So this is just a normal. You position the datum in through the center of gravity of the RAM at initial position. What does it mean? It means the datum is at the center of the system. Yeah? Okay, let me see. Okay, so I will just give you the schematic diagram. So this one before release, this one after. Okay, point 1 is before, point 2 is after. So what does the after the incident will happen? So here you will see W will always pointing down, and when you reach position 2, datum is from here. Okay, datum is from here. So you measure down 0.5 meter from the origin position, and there will be some displacement. There's some displacement of spring A. If you compress down, there's some displacement. And then this is spring A, this is spring B displacement. So this one later is just some early information. Later you will see in the calculation, you will include displacement of B and A in the relation. This one you need to relate spring A and spring B together, like the one you saw for pulley question. But this one we change to spring question. Okay, so the relationship of displacements of B is SA minus 0.1 meter. Why? Because the displacement of A and B, the difference between spring A and B is 0.1. Okay, 0.1. So when you want to calculate the displacements of spring B, you're actually using the diagram on the far right here to develop this equation. Spring A minus displacement of spring A minus 0.1 meter is the current position when the RAM A stop. Does it make sense to you? This diagram? Okay, maybe you need to some time to copy this diagram. All right, maybe give you 15 seconds to copy. All right, 15 seconds. So SA is the displacement done when the RAM A come to stop. What about SB? The displacement of spring, you need to take SA minus 0.1. Why 0.1? Because the initial gap is 0.1. Okay, let's move on. When you have this diagram, you can start calculating the energy. So conservation of energy, again, this equation is only consider conservation energy that you conserve. If there's a friction force inside, you put friction force inside this equation, is not a conservation energy. All right. So if you use this one, you only consider kinetic potential, before and after. So you write this conservation for energy equation, you will score some point. Then you expand what is all this. Okay. You expand all this. I write here for you. Before you start, kinetic is 0. Why? There's no movement before start. There's no velocity before start. And V here, V1 here, Y0. Look at this diagram. Why your potential is 0? Although you have some distance from the ground. Why? Huh? Why your potential is 0 when your object is some distance from the ground? Why? Huh? Anyone you want to try to answer? Why your potential energy is 0 before you start? You know that the potential energy is mgh, right? Why it becomes 0? Anyone want to try to answer this question? If not, I'm going to call out name. Let's see who is the lucky one. Huh? Okay. Steven, are you there?
Yes, sir.
Okay. Why before start your potential is 0? You understand why kinetic is 0, right? Before start?
Yes, sir.
Why potential energy before start is 0? Why?
I don't know, sir.
Okay. Let me try another one. Vinod, are you there?
Yes, sir.
Okay, Vinod. You understand why kinetic energy 0 before start, right?
No, sir. I don't know
No.
why it's 0. Yes, sir. Like
What is the equation of kinetic energy? Vinod?
what last bit?
What is
Bro,
the
so it's MGH. So it's like my monkey.
Sorry, what do you say?
MGH. That's the kinetic equation, right, sir?
I'm asking you, what is the equation for kinetic energy?
MGH.
Again, I'm asking you about kinetic energy. I'm not asking you about potential energy. You know that you know there's a difference between kinetic energy and potential energy, right? Do you understand you're having two different energy here?
Yes, sir.
Okay.
So you're asking kinetic, right?
I'm asking Vinod about what is kinetic energy equation.
Half mv square.
Okay. Half mv square is kinetic.
Uh,
Potential is what just now? Vinod, your answer is what?
I've confused that one, sir.
Huh?
Potential is MGH.
Potential is mgh. Kinetic is half mv square.
Yes.
Okay. What is your velocity before you start, Vinod? What is the velocity before you start? Can you find the keyword over here?
It's zeros.
Why 0? Any sentence here tell you that is 0?
Yes, it's at rest. That's it. Rest. Yes.
Okay, it start from rest. So your kinetic energy, half mv square, velocity 0. So your kinetic is 0. My question is, why when it start, your potential is 0? Why on the left hand side, I put 0 there before we start? What is the equation of the potential, Vinod? Vinod, are you there?
Sir, it's MGH.
mgh.
Yes.
Why it is 0?
That's what I don't know.
Okay, how you get 0, mgh, how you get 0? Does your mass become 0?
No, the h is equal to 0.
Okay, you look at the diagram I show you on the screen. Why h0?
So, sir?
You look at the diagram. Position
Like-
1. Position 1. Position 1. Why mgh, the h is 0?
I'm not sure so.
Do you see anything on the screen here?
Yes.
What is that? What is that? Can somebody tell our friend here what is this?
The datum, sir.
Okay. What does the datum do? What's the datum do in your calculation?
So,
What's the datum do to your calculation?
it makes
What?
the potential energy to 0.
Okay. So it will affect your mgh, it will affect your h. Just now, example number 8, why there's a negative sign? You still remember just now, example 8? Why we have a negative potential over here?
It's in the direction of the datum, sir.
It's below the datum.
Yes.
This is the h that you measure. How you know where is h? You measure from datum. Below datum, you get negative. Above datum, you get positive. Now back to our example. I guess you're able to answer the question now. Why your h is negative 0? Can you see the reason why your mgh, your h before start is 0? Still cannot see, Vinod.
Sorry, sir. It starts the datum, sir. Yes.
Where is your starting location? At datum, right? You start at datum, correct?
Yes, sir.
So what is the h from the datum?
What, sir?
What is the h, your potential for V1?
It's
You-
0.
0. That's why you get 0. Anyone else? You still don't know how to get 0? For example, number 9, why your potential in the starting point, why is 0? Anyone of you still not clear? If you're not clear, ask now. I'm going to randomly call your name.
Clear, sir.
Clear?
No, clear, sir.
Okay.
Clear.
Okay, good.
Clear,
So
sir.
before start, kinetic 0, potential 0. Again, potential always referring to datum. There's a purpose why the exam or test, there's a datum in the question. Datum always help you to calculate your mgh, your potential, your h. If the object above datum, you get positive potential. If the object is below datum, you get negative potential. If the object on the datum, you get 0 because it doesn't move. You don't have h. Okay, so look at the second part. Second part, you have kinetics, and we have kinetics and potential also. However, how many objects you have in the system? You have 3 objects. You have 3 objects in the system. Okay, before start, you have 3 objects. R, spring A, spring B. You have 3 objects. Basically, on the left-hand side, you should have more than 30 here, because anything doesn't move. So basically you can put 0 on the left hand side. This is just focusing on R only. The spring A and B also 0. Okay, more complete one, you will see 4, 0, minus 0, minus 0, minus 0 on the left hand side. A complete answer. But this is just to show you that we only consider R. On the right hand side, we start consider the 3 object. Kinetic energy for the R or for the RAM, this one. When it comes to position 2, what is the velocity? V naught. When it comes to position 2, what is the velocity? V naught. Answer? V naught, are you there?
So yes.
Okay. V naught, what is the velocity at position 2? Referring to this blue color item, or we call it a RAM. What is the velocity at position 2 for the RAM? Anything from here tell you that?
So
Can you relate this statement? What you need to find?
sir, it stops.
Okay. So when it stops, what is the velocity? What is your
It becomes 0.
0? So half mv square of your RAM becomes 0. I hope you can see, although I didn't write the detailed equation here. Okay, because at this stage, I already expect you understand the basic equation already. I straight away write the next steps. Okay, so you have clear for kinetic for RAM already. What is the potential of your spring? Oh, sorry, it's under here. So for RAM, right? For RAM, is your MGH at station number 2. You have minus W. Actually, this minus WH, I should put in front, but I put inside bracket because I have 0 in front. Okay, so for the RAM itself, when it reach position 2, you're actually having a negative potential. V naught, can you explain why you get a negative at position 2? Why your RAM R, when you reach position 2, your potential is having negative WH. Why? Why is negative
It's
WH?
below the datum, sir. It's below the
Correct.
datum.
Correct. Okay, very good. So this one is negative because you're measuring from datum. Below datum, you get negative. Where is your H? Is from datum to this position. We don't know. We don't know the H. Because what is the H of your R? Is this one to here, means 0.0.75 plus the SA is your H. Is where your RAM reach to this point here. Okay. We have clear for the RAM on the left hand side. 0 kinetic. Potential is negative WH. Next, we look at spring. Spring, we talk about spring energy. Spring energy equation is half Ks square. Okay. Spring energy is half Ks square. If you don't know this one, go back to the previous video lecture when we talk about spring energy. Go back to that video. So for spring, your energy is half Ks square. You have 2 spring there, spring A and spring B. Spring A, S is the displacement of A. Displacements of A. So SA square. For spring B, I already explained why the SB equal to SA minus 0.1. I already explained this now. I think 15 minutes ago. when I explain about this one. Okay, any question on this equation? No, the rest is just substitution from all the information you have in the question here. Okay. Okay, it's your homework. Substitute, rearrange. I give you the answer. You will get in the term of quadratic terms, because here you have s squared, you arrive at something xa squared, something as a minus something equals 0. This is a quadratic terms. It's a quadratic equation. Ax squared minus bx plus c equals 0. You are having a quadratic equation here. Solve the root for the quadratic equation. I believe you are learning your advanced mathematics or mathematics 2 or even calculus, solving quadratic equation, right? Now find the root for the square. Okay, assume this one is your x, this one is your x. Find the root for the quadratic equation. Okay, that one also I will leave it as your homework. Okay, because solving quadratic is, I assume you already have the knowledge already. Okay, SA equal to 0.031 meter. Why I pick the positive? Because you know your square root, when you square root, you have two roots. One is positive, one is negative. Why I put the positive? Okay, I pick the positive because it matched the scenario of our case. Okay, match the scenario of our case. Our SA is moving downward, positive. Okay, positive direction. Datum, positive direction. Our spring is going this way, that's why positive. The question doesn't ask you the bounce back reaction. Okay, the question asks you what happened when it come to stop. What happened to the spring? The spring is squeezed. What is the displacement? Displacement is going down. Where is the positive direction? From datum pointing down. Okay, so you pick positive 0.331. From there, from SA, you can find what is your SB from this diagram and this diagram. Okay, this one you derive from the diagram reaction. Substitute, you get plus 0.231. Okay, it is positive. Yeah. In the answer, both you get positive, means our assumption is correct, where the displacement is going down, where both springs are compressed. When the both springs are compressed, your SA and SB are positive and not negative, because of direction you measure from datum going down is positive. So when you compress your SA going down positive, SB also going down positive. That's why in your answer you get positive, positive. If you get negative, it means it bounced back. The spring bounce back means it's not logic. Means you need to relook into your calculation. Okay, this is how you make sense and explain your answer. So just for your info, in your test or exam, there will be one particular section ask you what is the meaning of the final answer. Meaning you will find something, for example, you find the spring displacement positive. Explain the direction of that motion. Either going up or going down. Okay, in this case, the spring is compressed with positive. It's compressed going down. Okay, so be sensitive to positive negative sign and make sure you understand what is the value mean to you. So if you understand the, this is just notes lah. Why there's a negative? Why we do not take the negative root of this quadratic? Go and read. Go and read. Any question? If no, we conclude this chapter over here. We will stop the recording.